Okay, folks, we've got this video for test number 22. It's another one of the tests that produced 100,000 points of data. I've made a modification to my version of the Access program. What I've changed is the overview data samples. I've gone from 1,000 samples to 4,000 samples, which is the maximum that this chart object will allow in Access. And it does produce a different looking chart. The bottom one here is a snapshot of when I was taking every 100 rows of data to produce the overview, and the current one that I'm using takes every 25th row. So we essentially have 4 times more points in here, and it's evident. We can see Microsoft has some sort of an overlap program where they deal with these points that overlap mathematically, and then they give us some sort of a graphical representation, which really looks like they're just overlaying each other. Is how they evidently get it visually onto the screen for us. But the nice thing is that this gives a little better view of the envelope, and which was completely missing from just 1,000 points of data, and so that makes it nicer. Plus, it changes our range now in the overview offset, so that we only have to go through 25 rows if we want to see everything. So instead of the 100. So I wanted to bring that up real quick. Another thing that I've created is this test table, which is basically just a summary of all of the sheets, their power averages, and the power maximums for each one of those. So that made it real nice. I was able to sort on this, and by sorting on it, then I could tell that we only have about a half a watt spread between any of the sheets, which is kind of nice. It's a pretty stable run. Now the power maximum tells a little bit of a different story. You know, we have a power max here on sheet 9 of 126, which was our lowest maximum power, and we have a maximum power on sheet 0 when the test began of 175 watts. What's interesting to me is that these two runs, or these two sample periods, are only 0.05 watts apart from each other. This is 9.55, this is 9.60, so that's interesting. Another interesting thing is that our maximum average, which was 10 watts, is somewhere in the median. And another point here is that we have 6 different sheets here that are spread throughout the test that all have the exact same maximum power, 134.64, when rounded to double digits. You know, that's actually there's 6. There's 6 of them that are identical. So that's kind of interesting. These are the kind of things you see when you can do a deeper analysis and have the data grouped together and look at it. Okay, so let's go on then. What most of you probably want to see is what the graphs look like for each one, and honestly, they look very similar to the one there from number 6. Most of them, you know, it looks like a mountain range of sorts, but there's a few of them that are a little bit different. I'll try and get them all squeezed in here if I can get my program to cooperate. We've seen this one before, this style where it starts off on one side of the 0 and then ends up on the other side by the end of the 400 nanosecond or 400 microsecond rather period. So see if we can step through this. Thought maybe if I didn't reload the page, maybe it would process the graphs faster, but it doesn't seem to speed it up any. I'm not going to take the time to describe these. I'm just going to go ahead and let you guys look at it, and I'll just put it up there for you. We've already seen 6. Six and 8 look so much alike that I actually went back to make sure that they weren't duplicates. They are separate runs. More of those mountain range looking envelopes. Well, I do think it is faster leaving it open. When I'm done with this video, I want to do a video on the Tektronix Open Choice desktop program, which lets us look at the CSV files in the scope view, and that way I can show you how it's possible to prove that the 40 microseconds per division data at 10,000 samples per screenshot is actually missing information. Fortunately, we had some snapshots taken and some CSV data taken that allows us to look at that. Okay, a little wider mountain range, huh? Ranges typicalis. And last but not least, 400 microsecond data for test number 20. And there's our 1 minute warning. You'll notice too that with the 100,000 samples, we have a lot more fuzzy spots that we can see on the waveform, so that's pretty cool too. Well, I'll leave you with this, and then I'll get that Open Choice Desktop video done, and then that'll complete the series.